There you go. My father's brother is my. You don't have to take the long way. So, however, whatever way works for you is the way you try, okay? You don't go. So people, then these confident, strong means. And we use, why do we use that mana? And so it's my dear children, right? Children. The mother is. Way up. And why do we go with a win and not much a win? So, how do we translate this in English? There you go. My mother. Mother. My. Grandmother is Abuelita, but if you wanted to say grandma, say Abuelita. Grandita, and then for the each one was grandpa. What? What? And people. Then we have a window. If we blink on the place. So, my friend, fun. Is my what?
Good morning. Were you trying to sneak past?
No, like that chair.
Oh, Eunice took your chair. Eunice is the chair thief. Chair thief.
I sit on the crowded couch.
Ugh, terrible, isn't it?
In my so
There you go, have at it. Drew, do you mind running downstairs and then letting me know if the copier is still printing stuff off?
cold in here.
I'm needing, well, because it gets warm really fast.
Sure.
What I'm needing is a document that ends, hang on, let me tell you what the last page number is, Drew. Whoops.
Miss Danny, what time is it?
Hold on a second, 8:61. It's 9:51. I'm looking for 8:61 as the last page, Drew. Will you let me know if it's still running, please?
So
Thank you.
all the extra ones, I decided I was gonna practice with one of them.
Smart.
So, but then I ended up really liking
Then
it.
you like it.
So I didn't.
Yeah. That'll work. Whatever works. Oh, it's you. Anyway.
So even if you feel something.
Almost got to forget Santa.
Huh? Put your name. There's the one from last week. I returned that one to you. Yeah, it was really good.
I'm happy. I won.
Yes, you did.
You think I'll make it 2 times?
I don't know. I keep them turned over so I don't see who they belong to.
So you know you actually draw.
Right. Yeah, I don't wanna cheat, you know. So I just keep them, I keep them hidden. I don't know whose is what. Is it got it all the way? 861? Less. Thank you.
Not until you like look at it.
Great.
That's a good you can't be wait I was excited when I saw we were learning about the
Words in the morning are fun, right?
yeah.
Mm-hmm.
What's it called? I'll get it in a minute.
It'll come to you. No worries.
Like how I personally I like how I made it like I kind of sketched out lab coat. Like
I like it. Very smart. Very clever. And it's not supposed to be here. And
But like your uncle.
excited. I have a hangout with one of my friends after this.
oh yeah? What y'all gonna do?
To Sugarloaf Mall.
Oh, that sounds like
I'm
fun.
gonna figure out things from there.
Okay.
There's a lot of things you can do there.
Yes. Yes, for sure.
Like there's an escape room there.
Mm-hmm.
A trampoline play. I
Yep.
guess I would need socks for that.
And this is like the best homeschooling thing because there's nobody else there, right? You get the whole place to yourself on a day like today.
Or at least for the first, at least when we get there.
Yeah.
And if we do go to like a place like that, they might have like a day during the
Mm-hmm.
day today.
Yeah, I like that too. When they give you when you get like special pricing or whatever for the day, that's super.
If we go see a movie, there would be a matinee special.
Yep. Yep. That's always good stuff.
Fancy for the day.
Yes, it is.
Like,
But it makes you feel fancier, you know, because it's a fun French word. So it's like super fancy. Woohoo. Matinee. Which is actually derived from the word for morning, which is matin.
oh, did, I was wondering if Landon's mom.
Yeah,
Okay, just-
I talked to Landon's mom. I felt bad for him. Oh, so he's your friend?
He's one of my good friends, his brothers.
I feel really bad about his arm. That's terrible. Sounds like he has to have some surgeries and everything to fix it. Yeah, it sounds really terrible. Makes me sad to hear that because nobody wants to deal with that.
Surprising, usually
Yeah.
you don't need surgeries for a young person.
Yeah, it depends on where it breaks. Sometimes like if it breaks in a growth plate or whatever, it's different than if it breaks just like somewhere along the shaft of the bone, and it depends.
I broke my elbow this summer.
Ugh. That's no good. What were you doing?
I took him for baby gate. No fancy story. I went climbing a cliff.
Yeah, you don't get to say anything cool. You're just like, yeah, just it's not stupid. Back in college, my husband was, he's a cyclist and he did a lot of mountain biking in college. He does mostly road biking now because it's just more accessible. You know, we can just get on a bike and go, as opposed to mountain biking, you gotta like go someplace to get off the bike, you know, take your bike somewhere. So he was mountain biking and he fell off the bike and got a knee injury. And he was in North Carolina at the time, doing like a co-op thing where he was interning.
I was in Ohio when I broke.
There
my
you go.
elbow.
So he was lucky because he ended up getting treated at the Duke Sports Medicine Clinic, which was really cutting edge in the mid-90s. So he was in physical therapy though with a girl who had completely torn her rotator cuff on her shoulder, which is this part. And how she did it is and this was a young girl, like not some older person that you might expect would have issues. Driving down the road, wanted to get something off the floor behind her driver's seat, reached back like that, tore her rotator cuff. That's embarrassing.
He said that I might have to go to physical therapy, but
Yeah,
I was all healed.
that's good. PT can be really good, but it's not fun. It's not usually a fun venture. They work you really hard. That's why if you have a really bad injury or you have to have like a really serious surgery, like a hip replacement or whatever, or you break something really bad, sometimes they will put you in inpatient physical therapy where you just like go and live at the place for a couple weeks while they do your PT. But that means they do it like 2 or 3 times a day. And it's really, really exhausting and really demanding, but it's faster and in some ways more efficient because at least you're focused on what you're supposed to be doing, because you can't skip because they can get you, you know what I mean? Because maybe like, I just can't do it again today. You know, if you were at home and you had to go to an appointment, you'd be like, oh, I just don't feel well, I'm not gonna go. These people come to your room and get you, so.
They can literally pull you out of here.
Yeah, that's what they do. They come and get you and they're like, let's go. My dad had to go to rehab like that twice, physical rehab twice after 2 different strokes, and both times they worked him really hard. And I have a friend whose mom is in a rehab right now. It was really weird. She started having seizures, but only in her legs. Like her legs, she would lose complete control of her legs. And she's like 80, so I mean she's old, but she's not, she wasn't infirm, like she didn't have major health problems, right? So she kept having issues with her legs and losing control in her legs. So they were like, well, it could be this, it could be that. The worst case scenario, it's a brain tumor. And it was a brain tumor. So a week and a half ago, she went in for surgery and they took the brain tumor out. And now she's in the inpatient rehab and she has to, she's managed to get motion back in her right leg, but she doesn't have any control over her foot yet. And they don't know if it's gonna come back. So her foot's just kind of like dropped and they don't know if she's gonna be able to get in control back, which is a real bummer. And we're like, oh, that sucks to go through all of that and then to not be back at full health afterwards.
I used to pillow on the
Yeah.
space.
You use what?
You should. I'm using this pillow on the space.
Go for it. That's what I do.
You should. She could cut her leg. She could cut her foot off.
Just
put
cut it off,
head,
yeah.
And say shark fit it off.
There you go. You could do that. I don't think she's that creative, but she's probably a little concerned with other stuff. Huh? I don't know. Did you eat it already?
Oh.
Well, it looks like the whole gang is here. So we did have a 7th student that was supposed to be in this class named Landon, but I confirmed with Landon's mom last week that he's not going to join us because he had a really, really bad injury to his arm and it's his writing hand and that just makes it really difficult. So if this is just going to be the crew, if you have homework that you need to turn in, the folders are over there on top of the chest. If you want to go ahead and be sure that it's there before you leave, you don't have to jump up right now, but Darcy's taking hers. So if anybody wants to hand it, she's too fast. There you go. Also, I found out this week when I attempted to update my iPad that I used to use to get video of the class while I was doing my lesson so that if you were absent, you could watch it later. that decided to fail miserably on me, and my iPad's too old to take the newest update, and Zoom requires the newest update to update Zoom, and so here we're stuck. So I know.
Yeah.
So I'm using the camera on my laptop, and we're gonna hope that works well. I've got the reverse camera on, so y'all are on camera like you should be every week. So we'll just hope this works. We shall see. All right.
Rico on the back of it.
Yeah, the one with Rico on the back is the one you turn in, and everything else you keep.
Yeah, I did that.
Good deal.
Okay, I want the Rico challenge.
She won Rico.
I didn't turn mine in last week, I forgot. I turned mine in this week.
There we go.
This was mine last.
It's much easier to grade the homework when it's through Teacheries, obviously. But I also enjoy doing it this way because I get more Ricos, and also because sometimes I get like I get doodles, people doodle in the margins of their homework, or I used to have a girl who would write down the lyrics to whatever song she was listening to, and then I would finish the line when I graded it. It was fun. We had a good time. All right, so we're gonna go ahead and start lesson 3.
Want this first? Does anyone want this?
What is that?
It's a drawing. I don't want it. Does anyone want it?
You can pitch it when we're done. All right, so we're gonna go ahead and we're gonna start and make sure it's doing all the things it's supposed to be doing. It is, and it's recording. I need to fix the recording to the local. Okay, so we're gonna talk about Earth now. Now we're moving on past our how to do science stuff, and we're moving into Earth itself. So this is physical science, not earth science, right? But it's important to have context. Like you can't really talk about the forces and motion and things like that that occur on Earth if you don't understand like where Earth is in the big picture. So that's kind of what this lesson is about. So let's see what we've got. All right, if you have a phone with you today or an iPad or anything like that, you can take it out and you can scan that QR, and it will allow you to answer questions as we go along. Does anybody have a device with them today? Anybody? Emma, you got
I
yours?
got my watch as well.
But I cannot use it because my phone is like a kid safe phone.
But it has internet, right? You can access internet?
Oh,
No?
I
Oh,
have a ton of screen.
a lot of them don't have, like cellular data, but that you can get hooked onto a Wi-Fi. So,
But I can't like connect to like a website, right?
bummer. Okay.
I hate that.
Well, here's what I will do then. I'm going to, when it comes time to get to these questions, I'm going to give you my phone, Darcy, and you can vote, okay? So how this works, if you have a phone and you want to bring it, how this works is it's called Mentimeter, and what it does is it allows me to put questions up that will show up on the screen, and they'll also show up on your device, and then you can vote on what you think the answer is, and the results are live.
It's like Kahoot.
Oh, is that one too? I don't know that one. Okay, so when we get there, I'll hand it over to you, Darcy, and you can, yes, Emma.
And if any of you yell at me to say put in that
Hang on.
answer,
Can you post the website on Teacheries, because I can like have websites allowed to me. I just
Yeah, it's in the slideshow, so you can always go back and watch the slides. And if you, like right now, it's on the presentation slides, but when you look at it, you'll see like at the top, it'll say like Mentimeter, and there's a code that you can put in, and it'll take you to the same questions. The thing it won't do is you'll be able to answer, but you won't be able to see all the answers. That only comes through me controlling it and projecting it.
this will be popular with your normal job.
It's fun. We did a little bit last week, so we're gonna do more. So let's talk about structure of Earth. Let's start with this. All right, so we're gonna have a blank here and then a blank in the next one. So what is the study of Earth? What do we call that particular field of science? All right, Emma?
Geology.
Geology. Okay, now that's an easy one. We can break it down. We do our Latin and Greek roots a lot in science, so it's important to know what's what. So this one breaks down into geo and ology, and instead of 2 O's, because we're not crazy, we don't do geology, we just do geology. What does ology mean? Do you guys remember? Emma, Darcy.
The study of.
The study of, yep, that's ology, biology, astrology, which is not the same as astronomy, right?
Yeah.
You guys know astrology versus astronomy? Do you know? What is it, Emma?
You repeat the word.
Yeah, astrology versus astronomy. Do you know the difference?
Astronomy is like fortune telling and like this.
The other way around. Yeah, astrology are the people that do like zodiac signs, and it's kind of fortune telling. Yeah, it's like future prediction with personalities and whatever, but astronomy is the study. Yeah, there's also cosmetology and cosmology, which are very similar. And cosmetology would be the study of what? Who knows? Cosmetology.
Makeup.
Yeah. No, you can say makeup. Yeah. Making yourself pretty is cosmetology, but cosmology is the study of the cosmos. And it's funny, my boys had a friend who in high school signed up for what he thought was cosmology, and it was cosmetology. And he was like,
Did he end up loving it though?
I think he ended up dropping it because he was like, this is not the class I meant to take. And then geo would mean earth, right? Earth in general. So when we see geology, it's the study of earth. All right, so then this next one is, what do we call scientists who study this? All right, Nico. Geologists, that's right. We put ists in the back of words that we are using to describe a person who does it, a chemist, a biologist. Sometimes it's also, well, there's physicists, but then there's things like veterinarians. We don't call them a veterinariist. That's another root that just comes in. And I couldn't tell you necessarily why certain things are picked over others, but such is. All right, so we can divide Earth into 3 big layers, and then one of these layers gets subdivided. So what is this outer layer? Eunice? Wait a minute, Eunice, crust. All right, that's the crust. That's our outer layer. That's what we're standing on, right? We're standing on the crust. Then what do we call the middle layer, Lewis?
Mantle.
That's the mantle. All right, and then our mantle is going to get subdivided, okay? It gets divided into 3 different layers. A lithosphere, I'm going to give you these. A lithosphere, an asthenosphere, and a mesosphere. Okay, so your lithosphere is where you are, right? I mean, it kind of is. Your crust, when you look at it, we'll see a video in a minute, but the crust is the tippy top, right? And then you got the mantle, but the lithosphere is the top part of the mantle. It's like where the mantle and the crust come together. So the closest part of the mantle that's like of any relation to you really is the lithosphere. And we can break down that word too. Litho. Does anybody know what litho is? You ever seen that word anywhere else? It's a tricky one. So litho is like stone or rock. And that makes sense, right? We're talking about the uppermost layer. It's rigid, so it's rock. And if you know anybody who's ever had like kidney stones, sometimes they go for a procedure called a lithotomy. And that's where they break up and remove the kidney stones. Have you heard that? Yeah. Otomy is removal of. So, or removal of, or kind of like alteration of. So have you ever heard of a lobotomy? You ever heard of a lobotomy?
Yes.
What is it? Do you know?
It's something to do with, oh my God, it's literally on the tip of my tongue, but my grandma had it, I think.
Oh, I hope not. So here's what a lobotomy is.
Oh.
This used to be really popular, not so much anymore. So a lobotomy is when they actually go in and they like scramble up part of your brain, physically scramble it up. So back not that long ago, y'all, not that long ago, like within your grandparents' lifetime.
Asylums they used to do that?
Yes.
Oh.
So they would go in, usually like through the corner of your eye. This is crazy. And they would take like a big rod and they hammer it in past your eye into your brain, into your frontal lobe. And it was a lobotomy because they would be like scrambling your brain because they believed that it would help cure things like bipolar or schizophrenia, something like that.
I used to live in the UK, right?
Right.
And the neighborhood that I was in when I was like a tiny baby,
Mm-hmm.
there was actually, it used to be an old mental asylum.
Oh,
and they
yeah.
used to practice that there.
Mm-hmm.
And like,
Yep.
tons of people were like either really messed up, most of them died.
A lot of them did,
Yeah.
or became catatonic afterwards and couldn't respond to anything because
Yeah.
their brain was quite literally scrambled, like you
Yeah,
would
I'm
scramble an
surprised
egg.
More people didn't die.
Well, here's something fascinating. So when this was the cutting edge treatment and it's what you wanted, yes, they would admit you to an insane asylum or a mental asylum. We don't use those words very much anymore. A lot of words that used to be the technical term are no longer the technical term. For example, do you know that idiot was actually a medical diagnosis? Yeah, it really was. Like idiot was a medical diagnosis. It was like a type of mental deficiency, and they categorize. You can look it up. It's fascinating. The words we use now that we're like, oh, we can't say that. That's demeaning. It's because it was the correct term, and now we no longer use that term because it was taken from being a scientific diagnosis to something that was used against people, you know, in a negative way. So we don't do it anymore. So that's where you get this whole litho thing, and we got to otomy, and then we got on a tangent. So asthenosphere, mesosphere. Meso's a good one you'll see in science very often. It means middle, which makes perfect sense because it is really your middle layer. And then lastly, we've got what at the very center. Okay, go for it, Carlos.
The core.
The core. All right. Yes, the core. And the core is, we believe it's solid, even though the stuff above it is liquid, and even though it's really, really hot, just because there's so much pressure. And we're pretty sure that it's made of nickel and a couple other things. Interesting. Very interesting. All right, so if I can get this to go. Now, did everybody see this guy? Did y'all watch this one? All right, so
we're not able to.
oh, you weren't able to get it?
You said type all the
Well, that's why, so you don't have to type all that. If you go to Teacheries and you click on the assignment, the slide, if you click on the assignment or you go to Dropbox and you find the assignment, yeah, all the links are there.
It's
Mhm.
really not working. Like we can't get to.
Yeah, it's having all kinds of problems, and
says error.
Yeah, it's saying. We
Is
can't-
it?
I had to type the links in the computer.
Oh, gracious. So since
It's written.
But I could not get the rock one. I tried the rock.
okay, so what I'm gonna do then is I want to make sure we go through all the notes, and then I'll go back and do the videos for these, okay? So basically what you have here is this one's goofy. It's entertaining, but it's goofy. You should be able to go follow links in Teacheries for future reference, so you don't have to type them in.
Great British Bake Off for like hours last night. It was so frustrating because they can't handle their time.
Yeah, okay, yeah. All right, 3 main types of rocks. So we have the type of rock that comes from magma. Lewis. Igneous. Yep, that's a tricky one. Igneous. Okay, so these come from magma, and magma is molten rock underground. When it comes to the surface, we call it lava, right? It's the same stuff, but it changes name based on its position. This is similar to meteor, meteorite, meteoroid. You know that one? So the meteoroid is the actual little rock that is flying through space. The meteorite is what lands on the ground, though it's even the same rock. And the meteor is the entire phenomenon of the rock and the flame and the light and the trail. That's all the meteor. So same thing with magma. It's molten rock underground. When it comes to surface, it's lava. And we have different types of igneous rocks. And here are some right here. We'll come back to those in a minute. All right, what is this next kind? This is when stuff gets squished together. All right, Eunice, you go.
Sedimentary rock.
Sedimentary rock. Okay, so this is sediment that's squished together over time. And these actually get further categorized into things like clastic, chemical, organic. Good examples of organic rock would be coal, because that is, what's coal come from? Do you guys know what coal comes from? Emma, what's coal?
Can be turned into diamond.
It can be.
Same thing.
Yeah, so it's carbon basically. So coal comes from primarily swamp plants, but it's basically dinosaur plants and animals that have decomposed and been compressed until they're underground. That's how you get coal. That's an organic rock. A good example of a chemical rock would be like salt that forms from a solution when the water evaporates. You get what's called an evaporite, and that makes salt. All right, Darcy, were you going to do the next one?
Yes, I was.
Okay, what is it? Go for it.
Metamorphic. But
Metamorphic.
it does say metamorphic there. You got those two mixed up.
Where? Oh yeah, I just didn't move the thing correctly. You're right. I put my little block in the wrong place. All right, so yes, metamorphic is changed by heat and pressure. So here's where we're going to play our little game. I'm gonna have to give you my, oh no, not yet, in a minute. We gotta do this first. Then we'll play our game and I'll give you my thumb.
Yay!
So- We have our rock cycle here. And you guys have this in your binder.
I'm sorry you did this.
So when we move from metamorphic rock to magma, what's the process that's going on there? Who knows? All right, Nico.
Cool.
Cooling? Think about it.
Wait.
You're going from rock to magma, heating, right? And that's actually a melting, right? So anytime you have a solid turn to a liquid, it's melting, even if it doesn't. There are some instances where melting seems like the wrong description, but it's right. So the rock is melting here. All right, now, when your magma becomes intrusive rock, what is it, Eunice?
Cooling.
That's the cooling. There you go. All right, there's our cooling. So this is when you've got your rock. Now it's cooling down. And then look here, you'll notice intrusive igneous rock and extrusive. Intrusive rock is formed underground. And extrusive rock is above ground. That's the difference. All right, now, how about number 3 here? How do we get our extrusive rock to move to outcrop position? All right, Darcy?
Erosion, like the ground will erode a little bit, or like.
Close.
Oh wait, no.
There's another one.
Oh, never mind.
Go ahead, Carlos.
Compacting and cementing.
No, but you're close. Emma,
It comes out of the volcano when it explodes.
close. All right, Eunice, last two. Uplift. Okay, that's what it's called when it moves from underneath up onto the surface where you can really see it. Now it's outcropped, which means it's visible. It's sticking out like a boulder. Then what happens to it for it to become sediment? What has to happen to the rock for the rock to turn into sediment? Nico, you know it. What? Weathering and erosion, right. So actually what you get is weathering, erosion, and deposition. So weathering is the process of breaking down the rock, and this can happen due to physical forces like wind and water. And it can also happen due to chemical changes, like, for example, some rocks contain soluble minerals. So when rain hits them, they dissolve. Like limestone's a great example of that. And then erosion is the actual carrying away of the weathered material. And deposition is when it leaves it somewhere else. So now we have sediment. Now what's going to happen to the sediment for it to become rock? Okay, Eunice, you go.
Burial, compaction, and cementation.
Right, we get burial, compaction, and cementation, right? And basically that's just it gets shoved underground, it's squished so hard that it becomes a solid piece. And then lastly, what happens to it in order for the sedimentary rock to become metamorphic rock? What has to occur? All right, Eunice again.
Heat and pressure.
Yeah, heat and pressure. So it's heat and pressure that change your sedimentary rock into metamorphic rock. And there are certain rocks, for example, like a silica rock, like quartz. Quartz can go from quartz to sandstone to quartzite, and it's the same material that makes up the rock, but it's in a different position in the cycle. Okay, so we'll skip this part because we'll come back to these. All right, now let me scan this. I'm gonna give Darcy my phone this time. Everybody could take a turn later if we keep doing this. Let's see. All right, now I should be able to start this question. All right, here it is.
Okay.
Obsidian, you're gonna take a guess.
Mine's
Why don't y'all,
Okay.
as a group, because she can only answer one. So why don't you as a group? You have to decide, is it metamorphic, igneous, or
It's
sedimentary?
igneous, guys.
It's igneous. How do you know it's igneous?
Because the book says so.
always black.
Because the book says so. Okay, sometimes obsidian is called, see your answer? Bing. Sometimes it's called volcanic glass. So obsidian is this completely smooth, no visible grain situation. And that means it actually cooled really
It
fast.
should look like that in Minecraft.
Yeah, so this is primarily like silica and some other minerals that have come out of a volcano and cooled so quickly that it didn't have time to form like nice big grains. It just becomes this glassy surface. So when I click next, I should give you the answer. Hang on, don't have to click on it. Is that how I get it? I don't remember.
It is
Whatever. Okay, here's your next one. This is nice. I know it looks weird. It's GNEISS. It's pronounced nice. And it's banded.
Yeah.
Are we going for metamorphic? Okay, put your vote in. Let's see what you get. All right, she says metamorphic, and that is correct. It is metamorphic. You can tell because it has that band in it. All right, now granite, sedimentary, metamorphic, igneous. What do we think?
Yeah, it's igneous.
It's igneous. All right, throw your vote up there. And here's your answer. It is igneous. Now, this is one that cooled more slowly. You can see the different grains. So these are different minerals that have cooled at different rates based on their chemical structure. They cool at different rates. And there's actually something called Bowen's reaction series, which is like a big, it's like a graph almost that shows you where different minerals cool based on the heat and the pressure. And it's really, really neat. You can always tell whether something cooled quickly or slowly based on the size of the grains. It is pretty neat, actually. Yep. All right, now here's our next one. This is my favorite of this category. This is conglomerate. What do we think?
Sedimentary.
Sedimentary?
No.
What you think?
It is, yeah, it's sedimentary.
It is sedimentary. And this is my favorite sedimentary rock because it's just funky looking.
I think I've seen one of those before.
You might. Now, I'll tell you this. In some places along the Great Lakes in particular,
Yeah.
there are a lot of these. Now, if you go to Michigan, for example, and you're hanging out on one of the Great Lakes, like I have a good friend from college who lives on Lake Huron. She has this beautiful historic house. She's a doctor. She has this beautiful historic house with a sandy beach, and it looks out at Lake Huron, and the lake's so big, it looks like it's the ocean. But they have these rocks wash up on shore that are conglomerate, but they're smooth because they've been tossed around in the water, and they call them pudding stones. Pudding being like the British description of a dessert.
Yeah.
So it looks like
So much.
almost like fruit cake. You know, it's got all these different colors, and some of them actually contain minerals that phosphoresce or fluoresce under black light. So you can put them under black light, and some of them glow.
I used to like
Very
collect
cool.
rocks, and I used to crack them in half. And one time I found like some shiny stuff, and I put it under a black light and little bits big.
Yeah,
I used
it's
to-
really cool. Okay, this one's quartzite.
Oh, that is definitely
Metamorphic.
Going for metamorphic. Toss your answer in there, Darcy. And that is correct.
Getting it right.
This is
So,
quartz, which would be igneous,
it went from
which turns
quartz
in.
to sandstone to quartz. No, wait.
Yes,
Oh, yeah.
very good. All right, so I'll snatch that back.
I love tectonic plates.
All right, what I think is fun about tectonic plates in particular is first the lab we do when we do it in earth science, which is super fun. We do a tomato soup and crackers lab, which is just great fun. But also the whole process of how we figured out it was happening. All right, so what's the theory? The plates or pieces of the lithosphere move about on the asthenosphere. All right, Eunice, that's our plate tectonic theory. All right, now, does anybody know or remember, it was mentioned, I think, in your supplemental lesson, the name of the scientist who, I think it was in that lesson, the name of the scientist who first put forward the concept of this next thing, which is
Mangia.
Pangea was, yeah, we're almost there. So Pangea is the name of the supercontinent that existed before. But there's this theory that the continents moved. Do we know what that theory is called? What is it, Eunice? Continental drift. Okay, continental drift is the theory that the continents have moved about over time. All right, so Alfred Wegener is the dude. All right. Alfred Wegener was this German scientist, and he was like, okay, look, people, there used to be one continent called, you said it was? Pangea, right? Carlos said it. Okay. So anyway, he says there used to be this one big continent, and he used different data. He used the type of rock found in parts of Europe, Western Europe, and then Eastern United States. He used fossils found on both sides of the Atlantic from an organism that was kind of lizard-like that we know cannot swim. So there's no way it would have been over here and over here unless it had a way to get there that involved land, right? So he used lots of different data. He also used a type of plant, like a fern type plant. And he's like, its fossils are here and here across the Atlantic. This plant doesn't swim, you know? So the problem was, even though this whole theory of continental drift was a great idea, the scientific community in general did not accept it. Here's why. He couldn't explain how it happened. He could show the data and be like, well, it looks like this happened, see? And they're all like, yeah, but how in the heck would that happen? It's not until plate tectonics was discovered that we could go back, and we're talking like not too much longer after, a couple decades later, they were like, oh yeah, Alfred, remember that thing you said about continents moving? Yeah, we think we know how that happens. We think you're right. Sorry. And he was right. And the way they found out that continents are moving and that the plates are spreading, so if you look right here at the globe, right here in the middle, right? If you were to look at like a topographic map that shows you mountains and valleys and things like that.
Oh, I should learn about this.
Those are fun, right?
Yeah.
There is a mid-Atlantic ridge, right? It's like this big trench, and then there's kind of mountainous stuff around it. And so during World War II, we developed some good sensing equipment so that we could sense out the ocean floor. Really, what we were doing was not looking for the floor. We were looking for submarines, like Nazi subs. So where are they? So we're scanning underneath.
Like battleship.
Yeah,
Yes.
but and some of it was scanning for magnetic data. So what they found was this. This is super cool. So what they found was at the bottom of the ocean, you have this trench, right? Trench running this way. Now, the North Pole is north, and the South Pole is south. And when you hold the compass in your hand, the needle goes where? North. Okay. That hasn't always been the case. The North and South Pole will flip polarity. So if you can think of it as positive and negative, there are times when it will be positive and negative. And that's happened throughout Earth's history. And it will happen again. And if it happens during our lifetime, it is going to be a disaster for so many types of technology that rely on north being north, right? All right, so as these flips occur throughout Earth's history, right here, you've got the plates spreading at the ocean floor, right? They're spreading towards the continents, away from one another. Ooh, I'm sorry, I didn't realize that. So anyway, you see this spreading going on, and it's molten rock that's making its way to the surface, right? And spreading out. Now, the rock contains things like iron, which is magnetic. And iron will align itself so that the negative part of the iron is attracted to the positive pole of Earth and vice versa, right? So you say you've got iron that's pointing this direction. And as it comes out like this, and then the poles shift direction, well, now it's pointing this direction. So if you look at a magnetic scan of the ocean floor, it looks like somebody took like mirror images of it, and you've got positive going this way, then negative, then positive, then negative, and you can see every polar shift printed out in the ocean floor. And that proved that, yup, that is moving, that is spreading, because we have evidence over time. And Alfred, sorry, dude, you were right. You know, all these years later.
Do you think the Earth, you think the continents will move anymore?
They are moving.
No.
They're actually moving at about the same rate that your fingernails grow.
2.5 centimeters per year.
There you go. It eats it, but they are moving. Currently, constantly, and always. And it can be seen, especially where you have faults, like along fault lines. You can really see it.
Yeah.
And what happens is the ocean floor plate is really, really dense and really heavy. You can think of it like it's heavy, it's very dense based on the kind of rock. So as, uh-oh, y'all okay? What happened? Their table collapsed. So as the floor spreads like this, right? Sooner or later, this ocean floor plate reaches the continents. The continental plates are not as dense. So it's called subducting, but it's so dense that it sucks under and then cycles around again. Yeah.
I have on Epic, I have this really cool video
Uh-huh.
that I like to watch about continental plates that explains it.
It's really cool.
I was really excited that we were learning about that.
It's really cool. And the mechanism that causes the motion is actually it's convection heating. So if you watch the lava lamp in here, this is warm. It's really this is wax, and it gets really hot. And as it gets hot, it goes up, right? But when it gets to the top, what do you suppose happens? It cools down. It cools down, and then it becomes more dense and it sinks. And then it cycles back up again when it becomes warm and less dense, right? So it does this constantly, up and down, round and round.
My mom was like, lava lamps, they were so
Mhm,
cool.
they are.
everything,
Yeah, but
like, no one knew how they
that's a perfect example of convection heating, and that's what's happening under your feet. You've got the mantle, and it's doing this kind of cycling of the rock, and that is pushing and pulling and causing the movement of the plates. That's why the lab we do in earth science, we do this crackers and tomato soup, where we put the tomato soup in like a shallow pan on the hot plates, and then we take crackers, and you can take like a Ritz cracker, and you can just break it a little, like so that it comes apart, but you can still kind of put it like a puzzle. And then you find kind of where you see the surface moving, like bubbling, and you can put it there, and you can watch them move apart, just like the plates do. And then you get to eat some soup and crackers, and that's fun.
Oh, that's gross.
So we have geologic time. We got to break time down into chunks because it's really, really hard to explain it otherwise. So what is, whoop, you got to see it for a second there. What is the longest period of time, Nico?
Oh, yeah.
Eon. And eon is the longest period of time. And sometimes people will say things like, gosh, I haven't seen you in an eon, right? That's a very, very long time. And then, whoop, that went fast. We all saw that. That's eras. Okay, so eras are made up of periods. So you actually have an even more detailed breakdown of geologic time. And then if you look here, we take that geologic time and we break it down into segments that we name. So we have, like back here, when you're talking about like Archean and Proterozoic, there's like, this is right where you get life for the first time, is like kind of like right in here. And you can see the kind of life we're talking about. Like at first it was just whatever that's supposed to be, little single-celled organisms that, you know, reproduced asexually by just dividing and making clones, that kind of thing. And then over time, we get much more involved stuff, and we're way, way, way up here. So actually, we can date stuff in two different ways. So one way we do is radioactive dating or carbon dating, and it involves isotopes. Now, when we do chemistry next year, we'll learn a lot about isotopes, but basically this, if you guys aren't really familiar with atomic structure, I don't know if you are or not, but you have an atom. There's an atom is the absolute simplest form of any particular element or substance that can't be broken down and still be that substance. Like this is the smallest you can get without breaking it down into stuff that's no longer recognizable. So you have an atom, and in the center of the atom is the nucleus, right? And does anybody know what's in the nucleus? Do you know?
The membrane?
No, that's
No.
a cell.
Right,
You're
right.
good though. That's good that you're there. Okay, Nico, do you know? Quarks. That's if you're getting subatomic. Let's go not quite that far down. So in the center of the nucleus, you have neutrons and protons. The protons have a charge. They're positively charged. Think of like a battery has a positive and a negative in. They have a positive charge. And this has to do, when we get into chemistry next year, we'll talk a lot about like molecular charges, but this is even smaller than a molecule. We're down to an atom, teeny atom. So around the outside of it, you have this cloud of electrons that are buzzing around. Those are negatively charged. And an atom in its, I know it's chilly, but as soon as everybody gets in here, it gets hot. So feel free to bring like a hoodie for the morning. So anyway, an atom in its normal state has got usually your same number of protons and your same number of neutrons, so there's no charge. They cancel out. I mean, protons and electrons, sorry. The protons weigh a little, the electrons weigh almost nothing. We talk about weight, mass. It's the neutrons that actually have some mass. And an isotope is when you've got your atom, but you've got a number of neutrons that's not typical. Like if you're supposed to have 10, but you have 11, it doesn't change the charge or how the atom is going to interact, but it does change the mass, and it makes it a little less stable. So over time, it will decay, which means it'll kind of change its structure, and it'll lose some of those extra neutrons or gain, depending on what you're dealing with. And then you end up with an isotope that you can track, because we know how long it takes for certain isotopes to decay. So we can go in and take a sample of something and determine exactly how old it is based on how much of an isotope it has versus what it should have had. So we can kind of like backtrack there and do some crazy math. And it's really, really cool. So this is the last Mentimeter, and I won't hand it to you because it's just this one. I'll just let you guess. So that's what we call absolute dating. Okay, because we can date it for sure. This, however, isn't absolute. This is the kind of dating that scientists do by comparing. Does anybody know what this one is? Anybody want to guess? Lewis, you want to guess? They can determine the age. It's a type of age. It's based on just comparing to what's around it. Nico? Well, the absolute's when we use the isotope. So what we're dealing with is relative. You ever hear anybody say, oh, that's relative? Like sometimes somebody will say, well, is a $200,000 house expensive? Well, it's relative. In the mountains of West Virginia, that might be expensive, but in Cupertino, California, that is as cheap as you're going to get. You probably don't want to live there, right? It's relative. It depends on what's around it. So in this case, relative age is based on a couple things. And the biggest one is this word probably looks like superstition, but it's not. It's superposition. So that's another one you can break down. Position is what? Position, right? Where something is. What do you think super means in relation to the word position here? Do you know, Emma?
I want to say like accurate.
Close. Good guess. Anybody want to get another guess? Want another guess? So in this case, it's going to mean above. Okay, so think about that. Super meaning above. That makes sense, right? So superposition will say that basically what it is it describes that the newest layers are formed at the top and the oldest layers are at the bottom. This makes sense, right? If you're laying down layers, like if you're frosting a cake, your oldest is at the bottom and your newest is on the top.
Ah, yes.
So if you look at this image here, okay, we got a stack of books. So this first one here, this is the absolute. This is the age time passed since the rock was formed. And we can use the radioactive dating that we just talked about on the last page to establish the exact age of a rock, absolute. And depending on how old the rock is, we can get really close. For things that aren't rocks, like we can use this also for structures. Like say they find an old house and there's wood in the house, or there's pieces of wood that are used and other pieces. They can take all that data and put it together, and sometimes they can narrow stuff down to really, really accurate, like within years or months. Sometimes here we can nail it down within, centuries or maybe millennia, depending on how old it is.
Yeah, millennia is not that.
Right. So thinking about, imagine you're doing your homework, and as you're working through it, you take each book that you've used and you lay it down, and then you keep reading and you lay the next one down. So, oh, the question can't be found. Oh, perfect. So it doesn't matter. All right. So the question is, which book, if we're doing law of superposition, which book did I most likely read first? Will we say green, orange, pink, or blue? Who votes? Which book did I most likely read first? Green, orange, pink, or blue? What's your vote, Emma?
Yellow.
Your vote? No, what? But my choices are green, orange, pink, or blue. What do you think?
Pink.
Pink. What do you think?
Orange.
Okay. What do you think?
Orange.
Orange. Green, orange, pink. So it would be orange. So if these books were layers of rocks, I would have read this one and then put it down, and then this one and put it down, right? So that is law of superposition. So it applies to more than just rocks. So we have time to watch. I'm gonna watch this one, and then I'll make sure that you have those other links. If you go to the assignment, so it's always under if you go into Dropbox, you can find it. I'll make sure it's under class participation and everything else. So you'll be able to find the links. You can watch them without having to type the whole thing in, because that's kooky. All right, so this is Earth's history as a football field. And it's really a great example. I don't know what Skunk Bear's about, but whatever.
Earth is about 4.5 billion years old. How do I even wrap my mind around that length of time? That's a good question.
Good questions.
How can you imagine 4.5 billion years? How does that compare to the amount of time it seems to be? The geologists gave us the idea to use a football field as a metaphor. And that's exactly what we're going to do. At this end zone, we've got the present. And at this end zone is the moment our planet formed. Earth's entire history stretches the full 100 yards in between. Every inch is 1.3 million years. Let's start at the beginning and take a walk through Earth's entire history. For the first few 100 million years, the Earth was bombarded by rocks from outer space. But now it's starting to calm down. And way up here, 2.8 billion years ago, life begins. We're talking simple life. Single cells floating in a vast ocean. Now these cells are figuring out new ways to get energy. They're evolving to harness the power of the sun. Photosynthesis starts past the 20-yard line. The air here is mostly carbon dioxide and nitrogen. But right around here, little green cells start making oxygen. And up here, about 2.3 billion years ago, oxygen starts building up in the atmosphere. We're halfway down the field, and we just got the kind of atmosphere that humans can breathe. For the next 1.5 billion years, it's paradise for single cells of every variety. But as we move down the field, cells start working together. And by the time we reach the 18-yard line right here, there's lots of complex critters floating around. It's 800 million years before the present. Things are about to get really interesting. Here at the 13-yard line, we've got an ozone layer. And here, a sudden explosion of diversity. Fungi, sea anemones, mollusks. 530 million years ago, animals take their first steps on land. In the ocean, fish appear. Land plants, insects, sharks, amphibians. It's been 4 billion years since we started, and here at the 5-yard line, we're just starting to see the first mammals and dinosaurs. We see Stegosaurus dinosaurs right here about 176 million years ago, but we don't see the T-Rex until about 4.5 feet from the end zone, about 68 million years ago. Look, the T-Rex is closer to us in the present than it is to the Stegosaurus way back there. Oh, there's a catastrophe at the 1-yard line. 66 million years ago, a meteor or volcano or climate change, or all three, killed 75% of all species. But life rallies. This yard is the yard of mammals. We got armadillos, giant whales, wolves, and here a foot away, the great apes, our family. Hippos, mammoths, lions, Lucy, almost human but not quite, saber-toothed tigers, cattle. Then 200,000 years ago, this is where we find humans that look like us. An eighth of an inch from the end zone, the width of this light bulb. This is all of human experience, but everything we call civilization, agriculture, cities, books, science, these don't appear until we're 2 years breadth from the sun. The width of this film.
Kind of crazy, right? Like you think of dinosaurs being so long ago.
Oregon State Bears for letting us do all this.
Thank Oregon State Bears.
To you, we say.
So yeah, it's way, way further back. It's way longer than we think it is. So I'll leave you this link too. This one's for radiometric dating. So this is your carbon dating. There's our Mount Rushmore. And how old are those for real? But I'll make sure that you have access to those and you know how to find them so you can watch them because they're all really good videos. So you guys didn't get to watch the radiometric, the continental drift, or the rocks, and lastly, what was the other one? Oh, this one with the layers of the earth and the Lego man. Okay, so what we'll do is we'll go ahead and get ready for lab. Everybody should be